Hello, my name is Maggie Monahan, and this is my lab report for Physics 2212, Lab 1, Charged Tapes. For this lab, it is important to note that ordinary objects can have excess charge, and there are experiments that can be done with household objects to observe this. In this lab, a clear piece of plastic tape is charged, and its interactions with other objects are observed. Then, the amount of charge on the tape and other calculations are performed. First, a clear piece of plastic tape is charged. A piece of charged tape is referred to as a U-tape. This is done by quickly pulling the tape off of the base tape, which is a piece of tape that is taped to the table or a hard surface. Interactions between this charged tape and a hand, a charged pen, and another piece of charged tape are observed. Also, the charged tapes should be handled as little as possible. If they are handled too much or come into contact with a lot of other objects, they lose their excess charge and their interactions will not be able to be seen. After this is completed, two pieces of tape, tape A and tape B, are charged in the same manner. Tape B is suspended and tape A is placed below. The interaction between these tapes is recorded, and it can be seen that tape A repels tape B in the positive Y direction. Details as to why this happens will soon be discussed. When observing the interactions between the charged tape in a hand, the U-tape is attracted to the neutrally charged hand. Then, a pen is run through hair. This is known to cause a negative charge. When the U-tape and the pen are placed near each other, the tape is attracted to the pen. When the U-tape is placed next to another U-tape, they noticeably repel each other. Through these interactions, it can be deduced that the U-tape is positively charged. This is true because it is attracted to the negatively charged pen and the tape is not neutral. It should also be noted that the velocity of tape B at the moment of interaction is 0. This implies that acceleration is also 0. If the tape is unmoving, then the net force in the y direction is also equal to 0. Force is equal to mass times acceleration. It is assumed that the only forces acting on the system are the force of gravity and the force due to tape A. Here, a model of the interactions between tape A and tape B can be seen. The distance between tape A and tape B is 0.021 meters, and the length of both tapes is approximately 0.2 meters. The arrows pointing out from each tape represent their positive charges. It is also assumed that the charge of tape A and tape B are equal. This is a reasonable assumption because they were both charged in the same manner from the same base tape. For the calculations, tape A and tape B will be treated as point particles, as can be seen on the right. Next, the force due to gravity is calculated by taking the mass of the tape times the force due to gravity, which is 9.81 meters per second squared. The force equals 0.001962 newtons. Then, this force and the distance between the two tapes are used to solve for the charge of the tape. The equation shown in the bottom right corner is used. The total charge of the tape is 9.805 times 10 to the negative 9th coulombs. Next, the number of excess electrons is calculated. This is done by dividing the total charge of the tape by the charge of one single electron, which is 1.6 times 10 to the negative 19 coulombs. It is found that the number of excess electrons is equal to 6.13 times 10 to the 10th electrons. Next, the fraction of atoms that give up electrons is calculated. First, the area of the tape and an area of an atom are calculated. Then, the number of atoms on the surface is equal to the area of the tape divided by the area of an atom. It is equal to 5 times 10 to the 16th atoms. Next, the number of excess electrons, which was previously calculated, is divided by the number of atoms on the surface. So 6.13 times 10 to the 10th is divided by 5 times 10 to the 16th, which is equal to 1.22 times 10 to the 4th. The same calculation process can also be done using Python. Here, a snippet of the code I used to calculate the charged tape and the model it shows using point particles. The blue sphere represents the point particle of tape B. The yellow arrow shows the force due to gravity, and the red arrow shows the force due to tape A. It can be seen that the arrows are of the same magnitude, but equal and opposite. This supports the fact that the net force is equal to 0 in the y direction. Both the calculations by hand and in Python each result in the same charge for the tape. In conclusion, this lab gave a better understanding to the concept of excess charge and shows that these interactions are happening all around us even when we may not realize it. The main goal of this lab, to find the charge of one piece of tape, was achieved and found to be equal to 9.805 times 10 to the negative 9th coulombs. Also, what if electrons had positive charges and protons had negative charges? Would anything change with this interaction? The answer would be no, because the charge of the two tapes would still be equal, and therefore they would repel each other because like charges repel. Thank you so much for listening.